Okay, so now here we are going to understand the complex numbers. So when we have the numbers, then what kind of things we can do on the numbers? That is first is called the addition. Like when we have to do addition of the two complex numbers, then what you can do? Then you can write, suppose I have two numbers, like I don't write here. I have two numbers here, Z1 is A plus IB and Z2 is C plus ID. As I told you that this number A is called as the real number, B is also real number, but this is called, if you just take the two numbers A and IB, so you just take it like this, A and IB. This is called the real part and this is called imaginary part. So if you have a number like, you can also like this, the real part of Z1 is A and imaginary part of Z1 is B. So when you are adding, then you, after adding two complex number, you are going to find another complex number, that is Z1 plus Z2. Now just add these two numbers, add the real part to real part, so you'll get a complex number A plus B plus I B A plus C plus I B plus D. So now what you see, that the real part of Z is real part of Z1 plus real part of Z2 and imaginary part of Z is imaginary part of Z1. Some people write IMG, I am also writing IM, not IMG. So REIM is good. So I am Z1 plus I am Z2. Like suppose if you have a number like 3 plus 2i, 2 plus 7i, just add algebraically, this will become 5 plus 9i. Number 2, subtraction. Subtraction, just like algebraical subtraction, so you get Z is Z1 minus Z2 and it becomes, like if you subtract here, like suppose if I draw a line here and subtract, then I get A minus C plus I, B minus D, B minus D. This is our subtraction, means the real part of Z here is the real part of Z1 minus real part of Z2 and the imaginary part of Z is imaginary part of Z1 minus imaginary part of Z2. Now multiplication is little tricky, so I want to clear that part of the screen and then we have multiplication. Multiplication, so Z is Z1 into Z2. So now we have A plus IB into C plus ID. So just multiply algebraically, just we multiply the two binomial terms, then what do you get? AC plus AID plus IBC plus I square BD. Now you know that I square is minus 1, so I can write is AC plus IAD plus IBC minus BD. So now you see there are two terms, this term and this term, they are devoid of any I, like there is no I, so you can say these two numbers are the real part, AC and minus BD. So you get AC minus BD plus I AD plus BC. So Z equal to AC minus BD plus I AD plus BC. So it means what you see, that the real part of Z is real part of Z1 and C, that is, so it is just like the mixture, real, imaginary, real part, imaginary, imaginary part, real. Nobody is going to ask you to write in this form, it is just If you want to go deep into mathematics, then just a statement, and later at the place of A you can write the REZ1, at place of B you can write IMZ1, at place of C you can write IMZ2, and at the place of D you can write IMZ2. So here AC means the real part of Z1 multiplied with the real part of Z2, and this is imaginary part minus imaginary part of Z1 multiplied with the imaginary part of Z2. So real, imaginary, then the real imaginary plus imaginary real. This kind of number you are getting to get in, and this is called the multiplication. Now division. In division, you have to apply a different trick. Like Z is Z1 over Z2. That is A plus IB and C plus ID. Now to get rid of the denominator from the complex nature, you just multiply it by C minus ID. This is called the complex conjugate of a complex number. What does it mean? The conjugate of a complex number is called as Z bar. So if Z is a complex number A plus IB, its conjugate is Z bar, that is A minus IB. If you multiply the complex number with its own conjugate, you will get A square minus I square B square, that is A square plus B square, and this number is purely real. There is no complex number. So when you multiply a complex number with its own conjugate, then that will give you a real number. That's why I want the denominator to be a real number. That's why I prefer to multiply both numerator and denominator by C plus ID is already there. So C minus ID and C minus ID. Now just multiply. So here you see that you get the line AC and the real. So imaginary, so you get the minus I square BD become the plus BD, and plus I am going to real imaginary, that is first I write positive 1, so I write BC first, and then I write AD over C square plus D square. Later you can write as AC plus BD over C square plus D square plus I times BC minus AD over C square plus D square, that is the resultant. This is your real part and this is your imaginary part. Same thing, if you want to express, sometimes they ask that express a complex number in A plus IB form, and they have given you something like Z equal to 1 plus 9 plus 4i. Better you just multiply with its conjugate, 9 minus 4i, and then you get 9 minus 4i, and this becomes always A square minus I square B square. That results into A square plus B square. So 9 square plus 36 is 81 plus 36. So 80, 30, 120, and I think 127. So am I right? 36, yes. So this number becomes 9 over 127 minus 4 over 127i. So this is about the simple operations. Now I would like to find the complex numbers root. Before finding out the root, we can also understand how the complex number plotted on a complex number system. So just let me clean the screen and then I'm coming back to you. Now just I want to plot these numbers on a grid, and that is called as argent plane. This is argent plane. Okay, so this number is called as this axis, which we generally call it as the real axis, that is called as imaginary axis, and this number is called as real axis. Real axis. Suppose if you have a number Z equal to A plus IB, and that number can be somewhere here. So this is your Z1, that is A plus IB. A plus IB. Now if you drop a perpendicular, then this is your A, this is your B, and this line is making angle theta with the positive direction of x-axis, that is my origin. Now if you just apply the Pythagoras theorem, then you can find that this distance is called as the magnitude of the complex number, and that is magnitude of complex number, that is mod z, is the distance of the complex number. Suppose this number is, I have already called z1, so I don't need this one. Suppose this is z1, so I can call it r also. Like this distance OZ1, that is the magnitude. Now if you just look at it in terms of this Pythagoras theorem, then you can find that this is under root a square plus b square, and that is r. So if you just try to recollect about the polar system and the Cartesian system, which I have already uploaded a video on that, then you can find that this b can become r sine theta, and this a will become r cos theta, and these are just the polar coordinates. This is a pole, and this is the point, and this is the reference line about which you have to find the nature of the pole. So now this complex number can also be written as z1 is a, what is a? R cos theta. So r cos theta plus I sin theta. Here also you need r, so better I provide bracket to this. A complex number z1 can also be written as r cos theta plus I sin theta. Now if you have studied, because if you are in class 12, then perhaps you may not be knowing this, but if you are in the higher, if you have studied the mathematics before, then you know that on the whole grid, and it goes like this, so it can be here also z2. Then if you join this, then in this condition your theta will become this, because angles are always represented by measuring the anti-clockwise from the positive direction of x-axis. That's why when the complex number z2 is here, then you get your theta here. When the complex number is here, suppose z3, your theta will be this, and that is obtuse, more than 180. And when it is here, when the complex number is here z4, another complex number, then its theta will be this thing or negative of this thing, because anti-clockwise angles are positive and the clockwise angles are negative. So here you can see. Now situation, we have discussed one thing called the magnitude of the complex number. Another property, that is theta, that is called the argument of a complex number, and that is called as ARGZ is what? And that is the theta. Now how to find theta? Because if the complex number is in first quadrant, then you have the acute, and your theta will be 0 to 90, and then when it is in second quadrant, it will be more than 90 and less than 180, and when in third quadrant, the thing is something different. Now there is one simple rule for that, how to find the argument or the argument of a complex number. Then you can follow the step number 1. Like if you have a complex number z is 3 plus 5i, it can be minus 3 plus minus whatever it is. So without thinking, just step 1, you find tan alpha equal to mod of a, this is the real part, and a plus ib. So a upon b, it means this quantity should always be positive. So your alpha will be tan inverse a upon b. Since we have taken the a plus b as positive in the mod value, so alpha you'll always get acute angle between 0 and 90. Step 2, check in which quadrant the step complex number lies. Like here you can say, if you just see the complex number a plus ib as the ordered pair of ab, then here both a and b will be positive. Here you have minus a and the positive b, here you have minus a minus b, and here you have a and minus b. So in this condition you have to check in which quadrant does the complex number, the given complex number belong. So if you find this, so you can find four situations: either the complex number is in the first quadrant, or it is in the second quadrant, or it is in the third quadrant, or in the fourth quadrant. If it is in the first quadrant, then your argument theta will be just alpha, whatever it was. When it is in second quadrant, then your theta will be pi minus alpha, because like suppose when my complex number is there, so my theta is this, but using mod value this becomes my alpha. So using this number minus a and b and putting this in the mod, I am actually finding out this angle, that is my alpha. But my real argument of the complex number is this, that is 4 pi minus this alpha. That's why it becomes pi minus alpha. Now when the number comes in third quadrant, your alpha is only this much, because you are just comparing this minus a and this minus b, both in mod values you are getting this value as alpha, but your argument actually is this, from here to here. That's why this number you can call it as pi plus alpha. So in the third quadrant your theta will become pi plus alpha, and in the fourth quadrant your theta similarly will become either 2 pi minus alpha or minus alpha. Just you can take the clockwise route and then you can ignore, because in the trigonometry you know that when you go for the angular span of the 0 to 2 pi, then the trigonometrical ratios just manage these signs and they give you the proper answer. You don't have to pay much attention to this sign. So this is all about the argument of a complex number, because when you have the complex number z, then here it has two important features. The argument is theta and the modulus a r is mod z. This is your modulus, and argument is theta. This is what we are finding here. This is all about the simple complex numbers.